Hi, everyone. Around 2 p.m. on Thursday, August 13th, 2026, there was a collapse of a bridge span for a bridge under construction in Maine between the towns of Stillwater and Old Town, Stillwater Avenue Bridge. This is something that you don't see too often, fortunately, and it's quite shocking. You can see that they were in the process of placing the concrete for the bridge deck on this span when it looks like it was a sudden catastrophic collapse. Three workers were injured. The most serious injury reportedly was a broken leg, and it could have been way worse. So, what caught my attention is, I'm sure it did everyone else, is why would a bridge under construction essentially break in half? It looks like the rupture here was mid-span, which suggests it could have been a problem with the bridge girders. And thanks to some viewers that reached out to me, they indicated that there was something special about the bridge girders for this project, and that they were composite, fiberglass reinforced polymer composite bridge girders. That is, they weren't reinforced concrete, they weren't structural steel girders. Apparently, this technology was developed at the University of Maine and was licensed to a local manufacturer there in Maine. I'm going to go through all the details, what we know so far, how these girders are manufactured, and what their application is. And there's some interesting postings at the Maine Department of Transportation website about this project that could yield important clues as to the underlying cause for this failure during construction. So before we jump into some of the general background as well as the details with this project, I thought I'd show you a few photos of these composite girders. These are photos from the Maine DOT website showing these girders being unloaded from a truck in preparation of being installed at the bridge. This is a photo of what one of these so-called tub girders looks like. Some information from University of Maine website on fiber reinforced polymer CT girders, these tub girders. So this technology was developed at the University of Maine and was licensed to AIT Bridges in 2019. AIT is a specialty manufacturer of bridge components, and apparently they're the sole licensee for this composite girder technology. Note here, following rigorous testing to determine their strength and fatigue resistance, G beams, as they're called, were first deployed in December 2020 for the construction of the Grist Mill Bridge on US Route 1A in Hampton, Maine. I think those had 75-foot long spans. Concept to deployment time of 5 years. So some of the features that they tout with this composite girder: high flexural strength to weight ratio, weigh as little as 1/4 of an equivalent steel girder, easy installation, corrosion resistant, depth and camber are easily adjusted based on project requirements, 100+ year service life. Now here's the project location in Maine. I mentioned between the towns of Stillwater and Old Town. This is an aerial photo from 2023. You can see the existing bridge. And by 2025, they had removed the existing bridge, constructed a temporary bypass bridge, and you can see off to the right, the new bridge is under construction. They've been working on this new bridge construction for over 3 years at this point. Looks like the overall distance across the river here is 533 feet. Now, interesting backdrop to this story. Apparently, the load rating of only 30 tons of the previous bridge at this location limited haul routes for timber. So the locals were really looking forward to having an upgraded modern bridge at this river crossing over the Stillwater River. Now let's get into some more details about these composite girders. This tout sheet indicates great for replacing and building bridge structures requiring short and medium spans up to 120 feet. Little to no lifetime maintenance. The composite girders require no concrete fill, making them significantly lighter than traditional concrete or steel beams. And again, they mentioned the 100+ year service life, and they're again touting the lower weight, which saves in transportation as well as installation costs. Now, this information is from the manufacturer's technical spec sheet for these composite tub girders, these CT girders. A structural member consisting of a fiber reinforced polymer, FRP, lamina composed of glass fiber, carbon fiber, foam core, and resin. And they've been talking about using this technology for this bridge over the Stillwater River as far back as 2019. And here's an article in Roads and Bridges about the use of these composite girders for a bridge in Maine. This opened in 2020, and some more articles on these composite girders, these tub girders. Now, it's been reported that the prime contractor construction manager for this bridge replacement project is a Woolwich, Maine company, Reed and Reed. Now, this is the most interesting aspect of this partial bridge collapse story in my mind, and that is information that's been posted by Maine DOT on this project website that suggests that there perhaps could have been damage to these composite girders that occurred at the time of construction. It also suggests the possibility to me of other mechanisms. I mean, you have to go through the whole list of things as part of a forensic evaluation. Was there a design issue? Was there a manufacturing defect? Was there damage that occurred to these composite girders during transport? Was there damage that occurred during installation? But let's go through some of these mentions here on this DOT website. So there's a mention in June 2026 of fiber reinforced polymer composites delivered for reinforcing Bridge 2 deck. That's the new bridge, not the temporary detour bridge. In May of 2026, crews installed bunks and deck formwork placed in cured concrete for the scenic overlook wall and added overhang brackets while addressing gaps that form between the deck forms and exterior lightweight composite girders by developing a mitigation strategy. So that sounds like a problem between the deck forms and the girders. And then April of 2026, they also performed welding of bearing and leveling plates and conducted inspections and repairs on composite girders to ensure structural readiness. Well, that sure gets my attention. Repairs on composite girders. So, what was damaged? Should these girders, if they were damaged, actually have been replaced? Were they was it reasonable to do this repair, whatever it entailed? And then March of 2026, crews focused on producing the superstructure and composite tub girder, making post-installation alignment adjustments as needed. And this is where we are today. I'm recording this video on Saturday, August 15th, 2026. This is the early going of any forensic investigation, but there's some, certainly in my mind, telltale indicators that should be investigated that's posted on the Maine DOT's website. So they could be facing a multi-year delay for the completion of this bridge project. It just depends what all the ramifications could be for this bridge collapse. Do they need to examine or reconstruct other parts of the bridge if there's a fundamental issue, perhaps with these fiber reinforced polymer bridge girders, these CT girders as they're referred to? It's a big question. So it just depends on the results of the forensic evaluation, but you just have to wonder what the implications are, not just for this bridge, but perhaps other bridge projects, as well as the future for this type of technology for bridge construction. So, again, thanks to you who have reached out to me and provided some interesting background for me to look into for this story. I'll continue to follow developments and post updates as we go. With that, I have another book mention for you today. Siddhartha by Hermann Hesse. This book was published in 1922. I absolutely love this book. It's a relatively short book, and it's written as what some people described in a very lyrical, almost poetic style. It's obviously very philosophically oriented, and I think it's just a wonderful book. So if you're so inclined, there's a link in the description. Big picture, it talks about the thinking and the development of a young person trying to understand what life is all about and making his way through life. So it's a wonderful book. I absolutely love it. With that, I want to thank those of you who've contributed to buy me a coffee. That's one of the better ways to support this channel. One of the main aspects that I use contributions to buy me a coffee for are paying for public records requests, which unfortunately is far too common. And I like to really get at source information for the development of the research for these videos. I also want to thank the channel members who typically preview these videos one or more days in advance, and those of you who've contributed to Super Things, additional great ways to support the channel. So stay tuned for future videos, everyone.